Now, there's two announcements. One you can't do. The other one you may be able to do. The first one, and this is just now for information, is that the new Student Success Center over on the Birmingham West Campus, just on the border of the West Campus, Wilson Road is the boundary between West and East Campus, and it's just on Wilson Road, is opening this morning right now. Okay, they're having the ceremony right now. They just sent me the thing yesterday, so I didn't have a chance to tell you, but I'm glad I didn't, so you wouldn't be tempted to go over there and miss class. Okay, so I'm glad y'all are here. But then in addition to that, there's also the new Resident Hall 2 is also ribbon cutting today. I guess after they do Student Success Center, they'll go across to East Campus and do the new Residence Hall. But what that means is those buildings are open now, so if you want to go see them, see what they're like, probably get someone to give you a tour if you're interested, you can do that, okay? Because the official opening, ribbon cutting and official opening is today. It's Birmingham West Campus is the Student Success Center and the Residence Hall. It's a little bit smaller than the first Residence Hall, but it's right next door to it. It's just off Wilson Road onto the East Campus. And this is the sad news. I know you as students would be very disappointed to hear this. You're also missing refreshments, okay? So they are providing those and guided tours, but I think you can get those later following the closure. So maybe right after class, there may be some left over, so you can rush over there and see if you can get a few. Never mind. Okay, and Jemiah came in. Anyone else come in since I called it? Okay. Okay. Oh, there is one other announcement. This is one of those good news, bad news situations. The good news is next week is spring break. But the bad news is we won't be meeting. Okay? So no class next week. Sorry about that. Get over it. Okay? Maybe Thursday I'll give you a test so you'll have some trig to work on during spring break. I care for you that much. Okay, so I'll be glad to do that for you. All right, so let's go from the current slide here. Wait. Yeah, I am recording. Okay, I want to make sure I did that. Yesterday morning's calculus class, I forgot to do that, so now I'm paranoid. All right, we had done example 7, no need to do that again. Getting ready to do example 8. First, are there any questions on anything we've done so far that you have questions about? And maybe it would be a good time, especially since I said I might be giving you something to play with over spring break. Let me remind you that this, one of my best classes ever, of course, I've only received 5 research papers. Now that's better than most classes, or many classes, I'd say most classes, but it's still, we only have, after spring break, 1 month left. That's all, so don't forget. Great time during spring break to be thinking about and working on those research papers. In addition to that, especially now that Caitlin and Bree are here, it would also be a great time for those few people, 2 people who have not turned in the first test to get those in. And by the way, neither one of them are here, so I'm preaching to the choir here. Hopefully they'll be listening on YouTube, so they'll hear that. But there's still the issue of test 2, which, pretty good. 6 people have turned in test 2 already, but I'm getting ready to give you test 3, so please get your test 2 done too. If you haven't gotten it done before spring break, get that caught up during spring break as well. Okay? So, let's get going on today. Any questions? Okay. Example 8 in your text, bottom of page 367, 5.3, chapter 5 is analytic trigonometry, 5.3 is solving trigonometric equations. Okay, so here is example 8. Whoops, let me get my pen set up. Okay. 3 times the tangent of x over 2 plus 3 is equal to 0. Oh my word. How are we going to solve a problem like that? Just a little bit of a reminder here. When you have these trigonometric equations, always first solve for the trig function, just as if that's a variable. Solve for it first. Then solve for the argument of the trig function. That would be, in this case, the x minus 2, x over 2. And then solve for x. So it's basically maybe multi-steps in between, but 3 big steps. Solve for the trig function first, the argument of the trig function, and then the variable. So what would you do first to start that process? Subtract 3 from both sides of the equation. Good first step. That leaves us with a 3 times the tangent of x over 2. That adds to 0 is equal to negative 3. Next, divide both sides by 3. You're solving for the tangent, okay? All right, I think we got that done. So now we have the tangent of x over 2 is equal to what? Negative 1. All right, now we solve for the trig function, now solve for the argument of that. What angle that when you take the tangent of it, you'll get a negative 1? Anybody? What angle when you take the tangent, you get a negative 1? Let's keep between minus pi halves and pi halves. That first period, period there. Galloway? Okay. What would be the angle? When you take the tangent of an angle, you get negative 1. What angle is that? It's not that hard. Anybody? Make a guess. Anybody? Second? Okay, pi halves is not defined. Remember, pi halves, tangent being sine over cosine. Cosine is 0 at pi halves, so you can never divide by 0. So stay between minus pi halves and pi halves. There's a vertical asymptote here. Stay something in between that. Make another guess. Anybody?
3/4 pi.
Okay. 3/4 pi will certainly work. Okay. That's going to be outside minus pi halves to pi halves. It's over here, but it's down here. You're absolutely right. Now, that is a place where it has negative 1. If you get it back to, we're going one, in fact, let's leave it there. Let's leave it there because they didn't put any limits on us here. So let's leave it right there. So that means that x over 2 can be equal, get out of there, to 3 pi fourths. Okay? Now, since they didn't put any limits on us, they didn't say keep it between minus pi halves and pi halves, how do we put the general answer for that? What is the period for tangent? Pi. So you put plus n pi. Perfect. Now, an n is any integer, positive or negative, including 0. That would work too. We're not really interested that much in what x over 2 is. We want to know what x is. That's what it means to solve it. So what would you do here? Multiply everything on both sides by 2. Okay? So that wipes out the 2 there. So you have x equal, and 2 will go into 4 twice, 3 pi over 2 plus 2n pi. All right, here's Stephanie. Okay. All right. There's your answer. Now, I bet you that's not the answer in the book. Okay? But it is the same answer. And here's why. Because if you took n to be, say, a -1 here, this would be then minus 2 pi. Well, 2 pi is 4/2 pi, so that would be 3 pi over 2 minus 4 pi over 2. That would be minus pi over 2. I bet you the one they list in the book, I don't know this for sure, is x is equal to minus pi fourths plus 2n pi. I may be wrong on that.
Yeah, they got the same thing.
Nope, they did it Patrick's way. Okay, sorry about that. They did exactly the same thing you did. All right. And this is Ariel's here. If I can find it, there you are. All right. Anyone else come in since wait. Perfectly fine. Okay. They did the 3/2 pi plus 2n pi. Now, why I was guessing they would have gone with this, because if you had done, you didn't need to, because we knew what the answer was. If you had done the inverse tangent here, which would have been a way to do it, we just knew it was -1 at that value. If you'd done an inverse tangent, that would have been between minus pi halves and pi halves. Then you would have had the minus pi fourths. Okay. They didn't do it that way, so they wound up there. Both of those are equivalent answers because these n can be any integer. Okay. So that's included here. This one's included there. If you let n be 1, okay, that will give you this one. So they're the same answers. All right. If you have issues with that, there is a checkpoint at the bottom, whether you do or not. Good idea to do the checkpoint soon after class. If you have issues then you can go to larsonprecalculus.com and see an audio-video solution for the checkpoint. All right. And I guess here's why they didn't use the inverse function, because that's coming up next. Sorry about this. I got ahead of myself. Okay. Using inverse functions. Here's example 9. Boy, they gave you a lot of verbiage. They just went right to this. Okay. Here is the original equation. What in the world do we do with that? Any ideas? What's wrong with the picture? What's difficult about that? Two different trig functions in it. How can you solve an equation, one equation with two unknowns? And that's sort of like what you're trying to do here, except these are not independent unknowns. That's a term from another course that you might get to in your future. But what can we do to rectify this situation? Say that again? Okay, now that is a possibility, try to get everything in terms of sines and cosines, but the odds are, though maybe not for certain, that you might still wind up with two variables, two functions, sines and cosines. But it may work out that you wouldn't, but I'm not going to bank on that yet. Something a little easier, though.
You can use the Pythagorean identity.
Which one?
The,
getting this, yeah. That's a good one. We're trying to get the secant squared to tangent squared because we have a Pythagorean identity to do that. It's going to be hard to get tangent to secant because we don't have an identity to do that. But we can use this one. The secant squared is 1 plus tangent squared x. Everybody agree with that? Or tangent squared x plus 1. It doesn't matter which way you do. There's that. So let's rewrite it that way. 1 plus tangent squared x minus 2 tangent x is equal to 4. All right. All right, at least now we got it in the same function. Well, what do we do with that now? Okay. And I think I might move one further over to the right. That would leave us with, okay, let's do the first. Subtract 4 from both sides, and let's go on and subtract it over here since it's over there. And that will give us a 0 here, because anytime you have a quadratic, whether it's in variables or trig functions, usually a good idea to get everything on one side, 0 on the other side. Okay? So what do we have now? You can rearrange the order now if you want to. Tangent squared x minus 2 tangent x minus 3 is equal to 0. And what? Ah, yes, let's factor that baby. Okay. Now, what's the only possible factorization for tangent squared x? Tangent x and tangent x. I can't write. Okay. Now we turn our attention to the sign of the last term, which is negative. And what does that tell you about these two signs? They have to be different. So we'll put 1 plus and 1 minus. Doesn't matter because tangents are completely equivalent. So 1 plus, 1 minus. Now, what's the only possible factorization of 3? 3 and 1. The question is, where do you put which? Any ideas? 1 positive, 3 negative. And the reason for that, the bigger number, the bigger absolute value, 3, needs to go with negative sign, so the negative sign wins in the middle. All right? One way to look at it. Silly way, maybe, but one way. But you can always check it, FOIL it. Tangent times tangent is tangent squared. That works. Minus 3 tangent x plus tangent x is minus 2 tangent x minus 3. Yes, that works. And we got a happy face to show for it. Okay. Now what do we do? Say that again. Set them each equal to 0 separately. That sounds like a good idea. Tangent x plus 1 is equal to 0, or tangent x minus 3 is equal to 0. Let's deal with the first one first. What would you do with that? Subtract 1 from both sides, and that gives you tangent x is equal to negative 1. Can't imagine what that could be, okay? Or, on this side, add 3 to both sides, and you get tangent x is equal to 3. So let's deal with the left one first, okay? What value of x will produce, when you take a tangent of it, a negative 1? Man. All right, negative pi fourths is what I read your lips to say, okay? So x equal minus pi fourths, or 3/4 pi. That works as well, okay? Now, they didn't give us any limits on it, so this is going to have to include a to make it general, plus n pi, okay? But what about the other side? I'm not sure that I know what angle has x has a tangent of 3. Don't think that's one of our favorites, is it? No, what are you doing touching away there?
I got 71.56.
Okay, what did you do to get that?
Did the
Inverse tangent. That is exactly how we get this. This one we knew, except he looked it up. No, he didn't. Okay, but this one we don't know. So that's how we get the next one. Do an inverse tangent of both sides. So inverse tangent of this, and an inverse tangent of that. Okay, an inverse tangent of tangent will be just whatever's left over, x, and this will be, what did you say it was?
71.56.
Is that in degrees? Oh, yeah. Mm-hmm.
It's 1.249.
Okay. So that at 1 point what? 249. And that we have to also follow with plus n pi. Okay. Now, I'm going to put a little wavy line there, approximately equal to. because this is a truncated value. It's a rounded value. It's not exact. This is exact. If we wrote out a decimal number for it, it wouldn't be, because that's an irrational number. But that also represents probably an irrational number, and that is not an exact answer, but it's close. So that's the closest we can get. What we did was take the inverse tangent. If it's not one of the ones we knew, then do an inverse tangent. Let's see, well, we're going to see how the book did it. Well, they've already started doing it. Let me erase mine. Y'all remember what I got, that we got, not just me, okay. And the first step they did was do the trig. Pythagorean trig identity for secant squared is 1 plus tangent squared x. And they also subtracted 4 from both sides. Then they combined like terms. They got tangent squared x minus 2 tangent x minus 3 is equal to 0. And then they factored it just like you did, except they did it in the reverse order. Tangent x minus 3 times tangent x plus 1. Setting each factor equal to 0. You obtain two solutions. This time they put you in the interval negative pi halves to pi halves. The previous time they let you go outside of that, which is okay. Okay, recall that the range of inverse tangent function is minus pi halves to pi halves. So we get x equal to arctangent 3. Now that is an exact answer. Okay? Don't know what the value is, but arctangent 3. And then the other, we didn't need to do that. We knew that one was negative pi fourths. Okay? And then to give the general solution, it's arctangent 3, which is not the same, well, that's how you got the number we came up with, plus n pi. But notice why we didn't use degrees. Because we're adding in pi to it, that's in radians, so you want to have that. So x equal arctangent 3, and that is an exact equal there, plus n pi, or x equal minus pi fourths, plus n pi. Those are your solutions for n is any integer. Actually, you really should always write that down, because n could be any real number, and that wouldn't be the case, only integers. Make sense? All right. So that was example 9. Oh, you can use a calculator to approximate the value of arctangent 3, which is exactly what you did. Okay. They're skipping examples 10 and 11, so let's go back and do example 10. Now, just like when you did quadratic equations in algebra class somewhere way back in your past, if you couldn't factor, what did you have to do? Quadratic formula, exactly. That's what we're going to do in example 10. Find all the solutions to this one. Sine squared x minus 3 sine x minus 2 is equal to 0. Oh, on the interval, thank you very much, on the interval 0 to 2 pi. Okay. Now, any of you got a big hankering to factor that? We certainly could try if you'd like. What you think? Anybody? Yay or nay? Still thinking? It ain't gonna work, is it? Okay? No way that will factor. If that could be a minus 2 times a minus 2, then you could have gotten a minus 3 in the middle, but that would have given you plus 2 at the end. So there's no way that I can think of to factor that. So guess what we use? Y'all got it right the last time. And how does that work here? We're used to being variables there, now we've got a trig function. We just put the trig function instead of the variable. Sine x, that's like the variable here, is equal to, and how does the quadratic formula go? Negative b, and what's your b here? So that would be 3 plus or minus the square root of, anyone remember? B squared, so that would be negative 3 squared, which is 9, minus 4 times your a, which is 1, times your c, which is negative 2. Okay, all over 2a, and a is 1, so that's just going to be 2. Okay, so that's going to be 3 plus or minus the square root of 9, what? Yeah, and what's 9 plus 8? 17. I don't think that's factorable, okay? That's not a perfect square. If it come out a perfect square, yep, you could have factored it. This is not, okay? And that's over 2. Uh-oh. So what are our answers? X is equal to the inverse sine of 3 plus the square root of 17 over 2 plus, well, we'll leave that alone for a bit here, or x equal the inverse sine, didn't come out too well, of 3 minus the square root of 17 over 2. Now, the only way to really give an approximate answer to this is to actually figure out what that is. This, I don't think, is adequate to just leave it in that form because, well, you probably could finagle it around some, but let's actually do that. Someone with a calculator, do 3 plus root 17, which is just barely more than 4, so this would be barely more than 7 over 2, so it's barely more than 3.5. And the inverse sine of the, ooh, wait a minute. Does that have an inverse sine? Is that going to produce something that's realistic? No! There is no number, angle, who has a sine which is equal to something around 3.5. Can't be outside plus or minus 1. So this one produces no result. Get out of there. Okay. Who? There's a second one. I forgot, left off my minus 1 there. This will be something just barely greater than 4. So this numerator is going to be something just barely less than minus 1. And that over 2 will be something just a little bit less than, meaning more negative than minus 1/2. Okay? Yes, that's within the range. What do you get? Well, okay. What do you get then? Negative 0.56. Okay. Happy enough with those 2 digits? I'm okay with it. Okay, now, is that between 0 and 2 pi? No, it isn't. So, is there a number that would work there? This is a sine, and this is an angle, right? What's the period of sine? 2 pi. So let's add 2 pi to that and you'll be within that range because you're adding a negative number to it. So this would be, so you could leave your answer like this and say plus 2 pi. Or you can do the decimal approximation of it and say plus 2 pi. I really don't care which way does the book do. Well, they gave a few more. Did you say negative 0.56? They got negative 0.5963. Did you do some rounding somewhere? Okay. Check it again on the calculator. 3 minus root 17 divided by 2. Now, make sure you do this. Make sure you do that numerator in parentheses. 3 minus root 17 in parentheses, and then divide by 2. Otherwise, you're doing...
I got the same thing.
Huh?
I got the same thing.
You did.
Negative.
They may have gotten it wrong then. Won't be the first time. Everybody else get the same thing? That he got, not the book got. Anybody?
Negative 0.561.
Say again?
I got the same thing he got.
You did.
Yeah. The negative 0.56.
Okay, right. Negative 0.5963? Is that what you got? Oh, you got the same thing he got.
Yeah, I got
Oh, okay. I didn't know which he you were talking about. Okay, so I'm taking it their answer in the book is wrong. Okay. Congratulations, class. You're the first ones to find that. So this is negative. Give me 4 digits.
0.5. 6.5.
Okay. For future classes, they'll know that's the right answer. Okay. Now, they also have another value, okay, besides this one. And here's why on this. Okay. If you can imagine, that's the graph of a sine function. It's pretty ugly, but just imagine it. But it also comes over here like this, okay? Now, we came up with an angle of negative 0.56. I guess I really should have done this as an inverse tangent. Okay. But that would have been, I'm just going to pick it somewhere down here. I don't know, somewhere about there. Okay. And if you see, that's going to be repeated here and here. We got this one when we added 2 pi to it, right? But we didn't get that one. So how do we get that? Well, that's this one here. Here's what you do. If you go over here to minus pi, okay, that's where this node is, and then subtract the same value you got here from there, you're going to wind up with this value here. So you do that. So it's a rather bizarre process, okay? And that would be, just ignore their 0.5963 and use your negative 0.5 Okay. Now, what they did is a little squirrely, or the way they did it is what they did is correct, even though they used the wrong number. Okay, except for that, they added pi to it, which basically, if you add pi to this one, okay, it's sort of strange, but you're winding up here, okay? You know, so you're at this value, okay? Well, that's not quite right. Well, no, okay. They took the positive of this one and added pi to it. That's what they did. They took the positive of that value and added pi to it, and that gave you that.
I think I figured out what I was doing wrong.
What's that?
So instead of taking the inverse sign of the whole function, I simplified the function first and got the answer we got, which was negative 0.56. And then took the inverse sign of that, and that gave me negative 0.596.
Oh, you were just giving me this answer.
Yeah.
Oh, okay. I mean this answer.
Yeah.
Okay, got it. I thought you were already taking the inverse sign. Okay, so their answer is right in the book. Is that what you're saying? They're so close, I couldn't tell. So theirs is right. Okay. You made me do it in ink, so now I got a mess in my book. But I'll forgive you maybe in a few years. Okay. So, I'm sorry. This thing right here was the negative 5.56. You see, so this answer here is 0.5963. Okay. Sorry. Okay. Got what you were doing. Okay. This answer was the negative 0.56. The reason they're so close, though, remember, anywhere for small angles here, this is really close to a one-to-one function. So, I mean, it is a one-to-one function, but it's so close to the identity function that that's why the answers are so close. So I thought, well, they could have made a mistake. But this is what the negative 0.56 was. When you take the inverse sign of that, you get that, which is a little bit off. But then what I was saying is what they did was, and this value was this value right here, okay? The angle that gave you that value here, okay? They did the positive of that, the positive 0.59 would give you the one up here because, you know, sine is an odd function, so that gave you this. Then you add pi to that, and that gave you this value. So it's a rather bizarre way of doing it, but it certainly is an okay way to do it. But when you add the 2 pi to this, you get that value here. Okay. So 2 pi to the negative value. So I guess their explanation, they say sketch the graphs, and then you notice that. I'm not sure. And they got the negative, now I see in the text, they got the negative 0.5616, 2, but that wasn't the answer to it, it was the other thing. Okay, got it. All right. But I still find their illustration of it less than satisfying. But I think if they had done this, said this is the value they found, and they showed that in the book, okay, right there. That's the value they found, okay? And then if you'd have done the positive of that, you would have done the one up here, and then add pi to that, and you get this one here. So that's how they got this one. And then they just added 2 pi to this negative here, and you get the second. So that they did do it right, but to me it was a little like mystery meat, what you have there. So, just because you get a solution, or what looks like a solution, check it out. And that's not going to have an angle whose sine is a big number like that, something greater than 3.5. Okay, so let's go on to example 11. Any questions on this one before we move? Example 11. Whoa, okay. I think we may just read this one, okay. Let's see. I don't remember. Yeah. The surface area S in square inches of a honeycomb cell is given by this handy-dandy formula I hope all of you remember. 6HS plus 1.5S squared times root 3 minus cosine theta. And it's pretty obvious where this comes from, right? I'm kidding, of course. Over sine theta. When theta is between 0, and they got it in degrees here, between 0 degrees and less than or equal to 90 degrees. Okay? And they tell you where H is 2.4 inches. This is very non-metric. Okay? And S is 0.75 inches. Okay? And theta is the angle shown in the figure. Okay? What values of theta give a minimum surface area? Oh, yeah. Pretty easy to do, right? Right. Analytically, hang it up, Jack. Okay, I mean, you can plug in those numbers and get a number here, a number there as a coefficient, but then you still got an expression in, and by the way, oh, this is a capital S, those are little s's, so don't confuse those. Why they use that, I'm not sure, but they did. You come up with this. Now, that's not an easily obtained solution by any stroke of the imagination. So what do? They say put it in a graphing calculator and come up with an answer. And that's what they do. So that's all we're going to do. If you've got a graphing calculator, do it. See, they plugged in their numbers and they changed the capital S to your Y, and your X is still your X, and they do 10.8 plus 0.847375 times that thing, and then have the graphing calculator graph it, and then say, tell it to find the minimum. And it did this, and when X is equal to 54.73 degrees, I'm just really surprised they used degrees, but they did, and Y is equal to almost 12, okay, is the minimum value. So it occurs with that angle of 54.7356 degrees, as if they have that much precision. Yeah, right. They can't have more than 2 digits of precision because your 2 constants you have there are only 2 digits. Okay, I'm not going to spend any more time on it unless someone has a question about it. Yes?
Is that 9.75 smallness?
Down here? Wait. Right here?
Yeah.
That's a 0.75. Okay. Yeah, sorry. Making fun of my writing. It doesn't hurt. I'm kind of used to it. Okay. So, anyway. Ready for vocabulary? When solving a trigonometric equation, the preliminary goal is to blank the trigonometric function on one side of the equation. May be a few words you can use there. I think I know what they're getting at. Isolate. In other words, solve for the trig function. Okay? Number 2, the blank solution of the equation 2 sine theta plus 1 is equal to 0 is theta is equal to 7/6 pi plus 2n pi and theta equal 11/6 pi plus 2n pi, where n is any integer. What do we call that solution when you have the 2n pi's or something like that following it? Any of you Army people? Senior most person in the Army, or Marine Corps or Air Force? General, of course, the general solution. Okay. Never mind. Okay. The equation 2 tangent squared x minus 3 tangent x plus 1 equals 0 is a trigonometric equation of the blank type. Hint, what's the maximum exponent? Two. Second? Quadratic, of the quadratic type. Right. Number 4. A solution of an equation that does not satisfy the original equation is an blank solution. We didn't say the word. You remember what it's called? If you go back to that one that we were just doing and we found out. Second? Extraneous, exactly. I really don't even see it in here. I thought I just skipped over it, but I don't see it. But we know that from the past. Okay. Oh, back when we squared both sides. Remember when we did that one? Yes, check for, back in example 6, check for extraneous solutions. So that's what they're looking for there. All right, homework exercises, and do any of the odds 5 through 9. They're all at calcchat.com, also in the back of your book. But CalcChat has tutorial help and worked out solutions. Back of the book only has the answer. Do any of the odds 11 through 27. They're all at CalcChat. 13's at CalcView as well. Do any of the odds 29 to 37. They're all at CalcChat. 29's at CalcView. Do any of the odds 39 to 45. They're all at CalcChat. 39's at CalcView. Do 47. It's at CalcChat. Do any of the odds 49 to 57. They're at CalcChat. Do any of the odds 59 to 69. They're all at CalcChat. 61's at CalcView. Do either 71 or 73 or both. They're both at CalcChat. 73's at CalcView. Do either 75 or 77 or both. They're both at CalcChat. 79 through 83. They're all at CalcChat. 85's at CalcChat. 87's should be at CalcChat. Let's see. 89 should be at CalcChat. And 91 should be at CalcChat. 93 is a meteorology problem, so you can take a look at that if you'd like. It should be at CalcChat. Another geometric problem. 95 should be at CalcChat. 97 should be at CalcChat. And there's 99's a true false. You can think about doing 101 and or 103 if you'd like. They're both should be at CalcChat. And there's something else on Project of Meteorology there. They seem to be liking that. And I can't remember if this guy's from Arizona, because it seems like he has a lot of Arizona, but I think that's my physical science book author. No, he's at Penn State. Okay, so I don't know why he's stuck on that. So anyway, that's it for 5.3. Any questions? This is all example 9 that we'd already done. Okay. So we've got almost an hour, right? No, wait. 25 minutes. I keep forgetting how long we got. Thought that would be a glorious day if we had that much more time. Okay. 5.4. That's right. Okay. We're now going to, if I can get my mind straight here, to Chapter 5, Analytic Trigonometry, 5.4, Sum and Difference Formulas. Y'all got tired of using those same identities over and over and over again. We needed some new identities, didn't we? Yes, a variety. Yes, absolutely. Well, the objective here is to use the sum and difference formulas to evaluate trigonometric functions, verify some more identities, and solve some more trigonometric equations. So, sum and difference formulas. Here they give them to us, and thank goodness they don't ask us to prove these. Okay, these can be done, but they are not really a pretty sight. So this is something that kind of, I'm not a memorizer, so I've never memorized these things. Basically, plan on looking them up if you ever need them, but if you use them often enough, you get to know them, like you know your phone number or your address, or at least your parents' phone number or something like that. I don't know my cell number. I never call myself, so I have to look it up every time. And I don't really care to give it to that many people because I want people calling me all the time. Okay, my wife knows it. That's all that matters to me. Okay, a few others. All right, so here's the sum and different formulas. And I can't do much more than give you a few hints. The sine of u plus v is sine u cosine v, same sign plus cosine u sine v. That's it. The product of the two different functions, sine and cosine, plus same sign, the product of the two functions but on the different angles. Okay. Then, if you can get that one down and get that one understood, then this one's easy. Because we know that the sine of u, so I'm going to say the sine of u everywhere, okay? The sine of minus v is going to be the opposite of sine v, right? Because sine is an odd function. Whereas the cosine of u is going to be cosine u, the cosine of minus v is still cosine of v because cosine is an even function. So this one's easy to remember. It's sine u times sine of minus v, which is the same, cosine of minus v, which is cosine v. That doesn't change. But over here, when you do sine of minus v, that changes the sign there. So again, sine u cosine v, same sign, SIGN sign, cosine u sine v. So basically, they're the same formulas, just when you change the SIGN sign, you do it in both places. Okay. All right. Trying to make sure you're awake. Now, cosine u plus v, a little bit different here. It's cosine u times cosine v minus the opposite sign here, sine u sine v. Okay? So they switch the functions, get the two cosines together and the two sines together, but with a minus sign in between. And then for the cosine of u minus v, then cosine minus v is going to stay cosine of v, but sine of minus v is going to change the sign, SIGN sign, so that becomes a plus. Cosine of u minus v is going to be cosine u cosine v plus sine u sine v. Now, tangent u plus v would be sine of u plus v over cosine u plus v, but that looks like a mess and a half there, okay? So actually the simpler formula is this one. And you could get it from there, but let's not. Let's just take it from here, okay? Tangent u plus tangent v, same sign there, divided by 1 minus tangent u times tangent v. So you change the sign in the denominator, 1 minus tangent u tangent v. And then if you do the difference, u minus v, tangent u stays the same, but everywhere you had a tangent v, if it becomes a minus v, that changes the sign because tangent's an odd function, just like sine. So that becomes a minus up here, and that changes this one to a plus down there. So tangent u minus v would be tangent u minus tangent v over 1 plus tangent u tangent v, which basically is just like this same sign on the top, opposite sign on the bottom. It's just a sign change. So, example 1 shows how the sum and different formulas can enable you to find exact values of some trigonometric functions involving sums and difference of our special angles. Those are the ones we love, right? Okay. So let's do it. To it. Find the exact value of sine of pi 12ths. And this doesn't mean plug it in your calculator, because that will be an approximate value. So what do we mean by exact value? Well, the place to start is to remember, what are our favorite functions? Can someone list them for me? Let me get my pen set up while y'all are thinking about it. I like 0. Okay. I gave 1. You give 1. What's another angle that you, in radians, that you really love and know well? Pi 6. Pi, that should be a pi, not a 5. Pi 4ths. Pi 3rds. And pi halves, right? Okay. Now, of all those 4 different denominators here, what's the least common denominator between those 4? Say again? 6, 4, 3, and 2. What's the least common denominator? 12. Okay, so let's write this in 12s, since we're dealing with 12s here. How many 12ths is pi 6? 2 12ths pi. How about pi 4ths? 3 12ths pi. Pi 3rds. 4 12ths pi. And pi halves. 6. Okay. Now, why do that? Just to remind you, here we want this to be either a sum or a difference of one of these angles, or 2 of these angles. It can't be a sum because all these angles, except for 0, are greater than pi 12ths. So any of these two have a difference of pi 12ths. Made it so it wasn't very hard. Any 2 of these have a difference of pi 12ths.
Wouldn't it be pi 6 and pi 4?
Pi 6 and pi 4ths, or pi 4ths and pi 3rds. Either one of those will work. Okay? So which one are you? The one you said first? Okay. So you can rewrite this as the sine of, and what did you say? Pi 4ths minus pi 6. Right? Okay, now do you remember what the difference formula was for sine? Sine of pi 4ths. Okay. Cosine pi 6 minus got it. Okay. So now the question is, what is the sine of pi 4ths? You said these are your favorite functions. You should know that, right? You know your friends and your favorites, right? You don't have to stop and think about it. Okay. What is sine of pi 4ths? Root 2 over 2, right? What's cosine of pi 6? Anybody? These are your friends, remember? Cosine of pi 6. Root 3 over 2. Okay. Minus, what's cosine of pi 4ths? Second? Root 2 over 2 again, because that's the diagonal line, right? And what's the sine of pi 6? 1/2. Got it. So what's that? Root 2 times root 3 is root 6 over 2 times 2 is 4 minus root 2. over 4, right? Which is root 6 minus root 2 over 4. That's the exact value. Now, you want to pull out your calculators and do root 6 minus root 2 and divide that answer by 4. Tell me what it is. 258. Now do sine of pi 12 and see what you get. Same thing. Exactly the same thing. That's the exact solution. And I know y'all are always wondering how you can find that exact solution without having to use a calculator. And now you know. Okay, good for you. Okay, so that was how are we doing on time? Okay? How much? 10 minutes, okay. Plenty of time. Let's see how they did it. To find the exact solution of that, they used the fact that pi 12ths was the difference between pi thirds and pi fourths. Hey, they can't do that because that's not what we used. We used pi fourths and pi 6, didn't we? Yeah, I thought we did. So they're probably going to get a wrong answer, aren't they? Oh, really? Let's see. So consequently, the formula is sine of u minus v, which would be sine of pi thirds minus pi fourths. And that would be sine of pi thirds cosine of pi fourths minus cosine of pi thirds sine of pi fourths. Well, sine of pi thirds is root 3 over 2. Cosine of pi fourths is root 2 over 2 minus cosine of pi thirds is 1/2. And sine of pi fourths is root 2 over 2. And sure enough, that gives you pi 6 minus root 6 minus root 2 over 4. And that's about 0.259. Both of them. Good deal. Any questions? Whoa! That was example 1. We jumped to example 5. So let's go back and do example 2. Let me know when we get close to too short a time. Find the exact value of cosine of 75 degrees. Is that one of our favorite angles? I don't think so. So let's do those angles in degrees. I'll do 1, 0. Okay. You do 1? 45. Okay, 45. Another one? 90. Second? 30. We know 30. That's one of our favorites. And 60. Okay. Is there any way you can get 75 out of those angles? Sums or differences? 30 and 45 add to 75. So this is exactly the same as cosine of 30 degrees plus 45 degrees. Okay? And what's the sum, the cosine sum formula? Cosine 30 times cosine 45 minus sine 30. That's pretty ugly. 3 sine 45. All right. What's cosine 30? Anybody know? Cosine of 30 degrees. Oh, pull out the calculators. Okay, which is root 3 over 2. Exact values, remember? Exact values, root 3 over 2. Okay? Cosine 45. Y'all don't really have favorites, do you? You don't really like these, do you? Root 2 over 2. Okay? Minus sine of 30. Anyone know that one? 1/2, and sine 45. Root 2 over 2 again. And what does this give you? Root 6 minus root 2 over 4. Haven't we seen that before? Okay. The last one, right? Which was sine of pi 12ths. Well, pi 12ths was exactly half of pi 6. Pi 6 was 30 degrees, so this is sine of 15 degrees. Well, how are sine of 15 and cosine of 75 the same? Should that be? Is that just one of those happenstance? What's the relationship between 75 and 15? They're what? They add to 90, mean they're complementary angles. And the cofunction of a complementary angle is a function of the angle. So yeah, these are the same. We knew that, didn't we? Okay. Not a surprise. Okay, so that was example 2, root 6 over minus root 2 over 4. Okay. Do we have time for example 3?
I have a question.
Okay, yes, absolutely.
So for that one, you just leave it as that?
That's an exact answer.
So the 0.258, that's an approximate.
What's that?
That's the approximate. The 0.258.
Where do you even see that?
I'm talking about for example 1.
Oh.
So for example 2.
Oh, I see. Yeah. Oh, wait. Yeah. Yeah, I see what you mean. Yeah, notice that squiggly looking equal sign there? Yeah, that means it's approximately equal to that.
So you can stop at that point.
Yeah, if it's asking for exact answer, that is the exact answer. Okay? If it's saying approximate, then use your calculator and see whatever you get. Okay? So, yeah, good question there. All right. Squeeze in one more or not? 5 minutes? Oh, yes, plenty of time. Okay. All right. So, example 3. Find the exact value of sine u plus v. Oh, we can't do that unless we know what. Oh, given that sine of u is equal to 4/5, where 0 is less than or equal to u is less than or equal to, oh wait, I'm sorry. Pi halves. So what does that tell you about u? It's a acute angle, isn't it? No, an acute angle, okay, between 0 and pi, okay, in the first quadrant. And they also tell you that cosine v is equal to negative 12/13. Oh, one of my favorite numbers, where pi halves is less than v is less than pi. Meaning, where is that living? Angle between pi halves and pi? My arm's breaking here. Someone come up with an answer. Huh? Quadrant 2, right? Okay. So, thank you for saving my arm so quickly. Okay. Now, does that even make sense? Is sine positive in the first quadrant? Oh, of course, everything is. Is cosine negative in the second quadrant? Yes, it is. That fits too. Okay, so we want to know what sine of u plus v is. Well, you tell me. This is equal to? Tell me, somebody.
Sine of 4 and 5.
Okay. Wait. Sine of u cosine, what's the formula? Oh, we have to go look, huh? Sine u cosine v plus cosine u sine v. Okay, we just plug in then, don't we? What is sine u? 4/5 times cosine v. Oh, we know what that is too, don't we? Negative 12/13 plus, what is cosine u? They didn't give us that. We can't solve this problem, can we? My suggestion is draw a circle. That sounds like a logical thing to do, doesn't it? Draw a circle and put an axis through it. And since we know sine of u is 4/5 and you're in the first quadrant, we know where we are in that circle. And we are going to make this a what circle? I'm not going to say a unit circle. I'm going to call it a, what's the hypotenuse? The sine of u is 4/5. 5. Okay, so we'll do, there's something like that, and something like that, and something like that. And we don't need these others, but I'm doing them anyway because I like doing them. Okay. Now, hypotenuse is that, and what in the world does the 4 stand for? What would that be? The opposite. So that would be the y value. So, ooh, I went too far. Okay. Yeah, well, actually not too bad. Okay. Now, don't trust my drawing anyway. Okay. Now, if the opposite side is 4 and the hypotenuse is 5, what is the adjacent side? How do you know that? 3, 4, 5 triangle, which is 3 squared plus 4 squared is 5 squared, right? 9 plus 16 is 25. So sure enough, the adjacent side of this angle here, and that's your u right there. It's u right there. I can tell it's u, right? Okay. And what's the cosine of u then? 3/5. We knew that. We got to do the same thing for the v. Now, I don't have time to draw it, but can we just go straight to the chase? It's going to be over here. Now the hypotenuse is 13, and the adjacent, because that's cosine, is going to be minus 12, and that's somewhere way out here somewhere. So let's do the same thing. 13 squared minus 12 squared will be your y squared, won't it? Do you buy that? Even if it's a minus 12 squared, you can put the minus 12 in parentheses and square it. Still going to be the same thing. So 13 squared is what, 169? Minus 12 squared? 5 squared. So the adjacent side here, the opposite side here is going to be 5. And it's going to be a plus 5, right? Because you're in the second quadrant. Okay, the y value is 5. So that's going to be 5/13. Right? That's going to be the sine of v. That was quick, but y'all followed it? Okay. So let's do the math here. That's going to be a minus 48 over 165, I believe that is, isn't it? Plus, huh?
Just 65.
Oh, not 65, sorry. I don't know where my brain was. Okay, and this will be plus 15 over 65, right? What will that be? Over 65. Okay. And that's going to be the sine of u plus v. Well, that puts us somewhere in the which quadrant? If this is your angle u, and your angle v is something like that, then you add this to that, and you're in the third quadrant, is sign negative in the third quadrant? Yes, it is. That makes me feel warm and fuzzy inside. Okay, so at least that part's right, and I'll trust the other part to be right. Feel okay about it? And let's see what they got. Oh, look at that, minus 33/65. Okay, I think that did run us out of time, didn't it? Okay, sorry about that. We'll pick up next time with example 4. Okay? All right, homework exercises here. We got a few done anyway. Any of the odds 7 through 9, they're at Calc Chat. 11 through 25, they're at Calc Chat. 21's at Calc View. Any of the odds 27 to 33, they're at Calc Chat. And I think any of the odds 35 to 39, they're at Calc Chat. 35's at Calc View. And I think you can try doing some of 41 through 45. They're all at Calc Chat. 43's at Calc View. And maybe 49 through 51, they're at Calc Chat. Okay, we'll leave those alone for now and do the rest later. Good deal. Thank you. All right.
See you Thursday.
All righty.